Hello, everyone, you friends of Euclid. Here we have from the Chapter 11 practice test, problem number 3, the SOHCAHTOA problems on the sine, cosine, and tangent. In the first two of these problems, which you see pictured before you, we're going to use one of these on each problem, one of these ratios, in order to figure out the missing side length. And so our first task is going to be, how do we determine whether we should be using the sine, the cosine, or the tangent in order to do that on these? All right, so let's take a look. So remember what SOHCAHTOA is for. It's an acronym that has been used, probably invented by someone who was very nervous about taking a test years ago, but it's a memory aid. So sine is the opposite leg over the hypotenuse. Cosine is the adjacent leg over the hypotenuse. Tangent is the opposite leg over the adjacent leg. All right, so how can we use this information about these three different ratios to decide which one we need to use in which circumstance, and then use it in order to find the missing piece of information? So let's take a look here. There's a process we follow. We're given this right triangle, this picture. All right, we locate our angle. That's kind of our anchor piece here. We're doing everything in relation to that. So once we've located that angle, then we have to ask ourselves two things. One, what information are they asking me to find? Which side of the triangle are they asking me to find? And secondly, which side of the triangle did they give me in this case? All right, so they're asking me to find x, and that's the opposite side from our angle. It is across, oh, sorry about that, that's kind of sloppy, but it's across from the 23-degree angle. So that's the opposite leg. And then they want me to find they gave me the hypotenuse. So they want me to find the opposite leg. They gave me the hypotenuse, opposite hypotenuse. This is sine. So we're going to use the sine. So the way we set that up is the sine of 23 equals x over 20, opposite leg over hypotenuse. All right, and then we just solve this the way you would solve any algebra problem. We want to get x by itself. Here it is. It says x divided by 20. So to undo divided by 20, we have to multiply by 20. So we will get our answer from this part, 20 times the sine of 23. Let's go to the and figure out what that would equal. All right, so we have got the Desmos calculator up. Let's take a look at it. Oh, it's already here. Sine of 23 times 20 is 7.8146, and so on. So we're rounding to the nearest tenth to be 7.8. Just a reminder also that the sine of 23 is an actual number, and it's this number. So we took that times 20, and we got 7.8. All right, so when you press sine of 23 in your calculator is saying, oh, the sine of 23, I know what that number is. It's this number here. And so it seems a little abstract that you're just entering this and you're not realizing perhaps that it's this number. All right, and I think I showed you the old trig tables that we used to be in the back of math books, and it was a little bit easier to understand that with those because it laid it all out in front of you. But your calculator knows what it's doing on this. So it's not an abstract type of variable or something like that. A lot of times people think that, well, that's a variable, but it's not. All right, so that is the first one. we said it was 7.8. So let's look at the second one. And we'll follow the same process. We're going to identify our angle. That's our anchor. And then we're going to look at what did they ask me to find? They asked me to find the hypotenuse. What did they give me? They gave me the adjacent leg to the 18-degree angle. Remember, adjacent leg just means the one that's next to it. It helps form that angle with the hypotenuse. Okay, so adjacent leg, hypotenuse, what is that? Cosine, adjacent and hypotenuse. All right, so let's set it up. I think as we're learning how to do this, it's a good idea to set it up each time. Adjacent leg goes in the numerator because remember cosine is adjacent leg over the hypotenuse. So I've got x in the denominator. So that's not too helpful. So 25 divided by x, to use the inverse operations, I would multiply both sides by x. That'd give me this equation, x times cosine of 18, which is a number, equals 25. So now we can divide by the cosine of 18. So we'll go back to the Desmos calculator and do 25 divided by the cosine of 18 and see what we get. 25 divided by the cosine of 18. Huh? Cosine of 18. And it's telling us that it's 26.3, which is correct. So you can put that one in there, 26.3. So x equals 26.3. Okay, that's finding a side length. Now, I didn't want that. Guess I don't need those anymore. So let's go here. All right, so that was finding a side length. Now, in the next two, we're finding the angle measure. And for this, we have to use the inverse values, but we follow the same process. If you get a process that works and follow that, you're gonna be in good shape. Here's still the angle that we're working with. So we have x, and then I've got what this time you notice what's different is since the variable is an angle, I have been provided with two of the side lengths. One of them is 25 and the other is 29. And what did they give me? They gave me the adjacent leg and they gave me the hypotenuse. It's across from the right angle. So adjacent leg and hypotenuse is the cosine, 25 over 29. So I've got this, but it's the inverse operation, or the inverse cosine, because I'm finding an angle. When I'm finding an angle, I use this. When I'm finding a side length, you won't see this because I'm using the main one. Okay, so let's go back to the calculator, see what it looks like. It's going to be, and if you're using the Desmos calculator, you need to, you'll notice that we don't have the inverse ones on here, so you have to go to this function button here. And we said cosine, didn't we? So we pick that. They got to go back to the main menu to get the numbers back. And it's 25 divided by 29. And that tells us it's 30.45. Okay, so we are instructed to round to the nearest whole number, whole degree. So we would leave it at 30 because it's 30.4. If it was 30.5 or higher, we would do 31 degrees. So going back to our presentation here, it is 30 degrees. Got one left. So let's take a look at it. Okay, once again, all the same process. There's the angle. And what did they give me here? Notice the hypotenuse has no information, but they gave me the two legs. So there, because of that, we can use the inverse tangent function. What's the opposite leg from the angle? It's the 33. So it's 33. And what's the adjacent leg? It's the one next to it. That's 31. So now we're going to go back and use the inverse tangent. 33 divided. So let's take a look at that. Once again, we have to go to the function one to get it, and here it is, tan to the negative 1. I think, if I remember right, it was 33 divided by 31. If it isn't, we'll find out soon enough that we have the wrong answer. Okay, 46.78, which would round up to 47. That is correct. All right, so that's how we do this. So we would say it's 47 degrees. That's the whole thing. All right, so remember that. Finding a side length, that's the main function button. If you're finding an angle measure, you use the inverse function button with the -1 on it as superscript for that. And so remember that, remember SOHCAHTOA, remember that the process is the same. Find your angle, use that as your anchor, and then look at what other information you have and determine which ratio you need to use. And that's it. All right. Have a geometric day. Thanks for listening.